A couple more examples of multiplying fractions is bringing in some other operations that we've been dealing with. We've been learning to get used to seeing variables in our expressions and equations and exponents. So how do we work this? And the other thing is this 30 is not a fraction. So how do we multiply a fraction times a whole number? Well, first of all, we want to think that every number can be represented as a fraction, except for something that's called irrational numbers. So every rational number can be represented as a fraction. So a lot of your decimals, all of your whole numbers, all of your integers, all of those can be represented as fractions. And we'll learn a little bit more about irrational numbers later on. But for now, we're only dealing with rational numbers, and rational just means you can put it into a fraction, okay? So when you see a whole number, just imagine it as a denominator of 1 underneath. So whatever the whole number is, you put a 1 underneath, because really this obelisk, this fraction bar, is a division sign. So 30 divided by 1 just equals 30. So we're really just dividing everything by 1. So when you look at it like this, it can make it a little bit easier to know what you have to do. You're just multiplying across the top and multiplying across the bottom, and then reducing at the end if you can. So let's look at this one. So this one, we have a variable here. We have no idea what it is, but we can't just ignore it. But what we can do when we're multiplying, we can multiply this whole number, the top, by this whole number. So 5 times 30 is going to equal 150. And this m is just going to tag along because we don't know what it is. But whatever it is, you're going to be multiplying it by 30 and then by 5. You're multiplying it by those two. So we might as well just go ahead and do 5 times 30 and simplify that and get it as 150m on top. And then on the bottom, 6 times 1 equals 6. And we could reduce that. Obviously, we can divide by 3 for sure. I don't know if you can divide by 6. But another way that some people have learned is reducing these first instead of reducing at the end. So I kind of just want to go over that really quick for those of you that might see it better this way. So we already know how to reduce at the end. But what happens if we reduce now? Well, if we're looking at the fractions that we're multiplying and we want to reduce at the beginning, what we have to do is do cross cancellation. So the numbers that are catty corner to each other. So we have a 5 and a 1, and those are both prime. We can't reduce those at all. But we do have a 6 and a 30, and I can reduce this because 6 can be divided by 6 and 30 can be divided by 6. So I could rewrite these numbers and reduce them now, and it'll make it a little bit easier to reduce now than later because I'm not dealing with that big 150, and I don't know all my factors of 150 and what all goes into it. So what I'm going to do is divide both of these by 6, okay? 30 divided by 6, so our new fractions are going to be 5 over 1. 6 divided by 6 is 1. And then we're multiplying 30 divided by 6 is going to be 5. And then we have a 1 right there. So now we have 5 times 5 on the top and 1 times 1 on the bottom. And that would equal 25 over 1. And any answer that ends with a 1 on the bottom, you can just write as a whole number. So 150 is, like we had that 150 over 6 before, we could divide 150 by 6, but some of us might not know that right off the bat. So this is just another way. You can always reduce at the end if you want to and go through your factors, and that's fine. But this is just another way of getting your fractions into another equivalent form to kind of do your reducing ahead of time instead of at the end. And then you're not dealing with such big numbers. Now, I did forget about my m here, so let's not forget about that, because this m tags along the whole way. So we have an m right here, which means 5 times 5m is going to be 25m. So let's make sure we add in our variable at the end. Another thing we might see is fractions with exponents. So this is a little tricky, but once you get the hang of it, you just have to get used to your properties of exponents. So right here, because this exponent is on the parentheses, that means this exponent is attached to everything on parentheses, okay? So you could rewrite this as 4 squared over 5 squared, and then kind of just get rid of those parentheses altogether. Because all these parentheses is saying is that this 2 is on every piece inside the parentheses. So we know from there, 4 times 4 is 16, 5 times 5 is 25, and there are no common factors between 16 and 25, so this would be in lowest terms already. So that would be our answer. So you'll see a couple problems like this in your homework. And again, we're just trying to make sure we're not forgetting how to use exponents and we're not forgetting about our variables. We still want to get used to using them and seeing them and learning how to deal with them when they're in expressions and equations. Again, because we use exponents and lots of variables in algebra.